Alright, so we're making interesting progress here, and we've come to the conclusion that we need to describe a shape. And we've in a couple of different ways of describing that shape, have called it a ring. We've also called it a square. So it's interesting to try to figure out, like, what's the essence of this problem and what do we need to look at to sort of simplify understanding where this coin can land.
So I guess I can kind of attempt to draw what we're looking for.
Okay. So
we've got, this is our big square, what we're trying to have the penny land inside of.
Yeah.
And we're going to have the edge, and then kind of go over here, another edge, another edge, another edge,
yeah,
kind of like this, and then tracing out the inside with just these cases is going to be some sort of square. I don't really know. It is.
Okay, and what is the important thing about that square? Is that like the winding cap in?
Well, that square. Actually, I think we've just been thrown off by the size of what we're using. Because this is the diameter of the penny. This is 0.75. As is this.
I'm not sure that's true.
So, well, if we had a penny, I mean, we don't, because we're kind of thrown off by how small this is in comparison to the square.
Well, but even use that. What is that length that you draw? Is that the diameter of the penny?
I think it would be. I would just drew this very wrong if it is. Because I think
maybe I misunderstood your picture. So this is where you're saying the other side of the.
Mm-hmm. That's where.
The other side of the coin.
We just take a diameter.
Yeah.
Ah, okay. All right.
So
I don't think that.
In reality, the square doesn't actually exist. Because it's 0.75 on each side, so that's going to sum to bigger than 1.
Okay, but
so,
nonetheless, this thing that you've drawn here does seem to correspond, roughly speaking, to when our winning parts, and we think it's somehow associated with a square. And we got to try to find the square.
So I guess what we can do is since this shape's kind of complicated, we've got straight lines and curves, we can try to chop it up into things we know how to plan the areas of.
Okay.
So we can do this, and then we get
Find those lengths.
4 rectangles, 4 bits of circles that we don't really know what they are, but they might be
a square.
And then we have our central square.
Okay, and what does the central square here represent? Try even putting the coin on here, on this picture, and see if that gives you a hint.
So we go like this. The central square might represent like this, like the area that this outer edge of this edge of the coin is sort of tracing out.
All right.
Maybe even like in reverse, because you're going to go over half. Because the coin's kind of really about this big.
Oh yeah, that might also be true. So if the coin was very big, it sort of, if your coin was going over here, it might trace out this. If the coin was going, then it was going this way, it might trace out this.
Yeah, so if we have a problem if we have this outer edge issue with this square, that creates an interesting problem. So the question is there a simpler thing we can use with the circle instead of the outer edge?
With this part.
With the circle.
So
So you're talking about the outer edge of the circle.
Mhm.
So is there something else we could use with the circle?
we could use the center and see what that would look like.
Okay. Why don't we do that in the next video?